Good evening, guys. All right. So at the moment, we're going to be talking. Sorry, have some coffee on me. We're going to be talking about persistent data management with Python. So that is actually persisting your data to a database with Python, right? Because in the usual way, you use a dictionary. So for example, I have my dict equals whatever, and then I add some stuff to it. Like that, whatever it might be. That goes away when my program stops terminating. Well, most of the time you don't want that to be the case. You want things to be persistent. So that is, even though my program terminates, that data is still kept somewhere, and that's kept in a persistent database. Now, there are about 10,000 different kinds of databases. The one I'm going to be using today for this is called SQLite. So if you want to mess with this yourself, installing SQLite is kind of system dependent. So you'll have to Google it. But SQLite is basically just a file-based database that is a smaller flavor of SQL, meaning you have a big database that's that keeps a series of tables, and each table has some columns. So for example, you'll see my terminal here. I open this testdb.db. That's my database file. Using this program called SQLite 3, which opens this little terminal thing. It looks like the Python terminal, but this is for SQL. So then I use this command called .tables, and I've created this table called user. Well, this table user, is it describe? No? Hold on. Like I said, there's about 1,000 different flavors of SQL. It's hard to remember which one has which commands. Excuse me. Schema. Okay, that's what it is. There we go. So here, it'll show you the create table statement that I used, where it says I have this username, which is text, which is like a Python string, and this password, which is text. So this is going to act like a normal table you would see just like in math, where I just have a bunch of rows, with these two columns. So for example, I could insert some stuff into this guy. Now, of course, in this case, I'm just storing plain text passwords, which is a horrible idea. I'm just forgetting my SQL today. But for the sake of example, it doesn't really matter. Plain text password. So this insert statement inserts some values into my table, and then I can do this select statement to see what was in there. So you can see now inside my table, I have pgreasy and password. So if I quit out of this, and I go back into it, then you'll notice that when I select again, that stuff is still in there. And it's going to stay in there until I either delete the table, or I go and delete that particular set of data. Anyway, that's all fine and dandy. But I want to be able to manage all this in Python. So how do I do that? Well, there's this package called SQLAlchemy, like that. And we're going to go through each one of these imports, and I'll show you what it does here in a minute. But SQLAlchemy is a Python package that helps you manage SQL-based database systems all in Python. So to get SQLAlchemy, I use the packager pip3, in which case you would just pip3 install SQLAlchemy. If you're more fluent in Python and you want to use something else, that's more than fine, as long as that's in whatever install you're using. But for most people, they just use pip3. That is something, it ships with Python on most systems, I believe. I think on Windows you might have to install it separately. But anyway, I already have it installed, obviously. So you can see there, hey, already satisfied. Cool. Now, when I'm working with a database, and I'm not in the database directly, so when I was doing the SQLite stuff earlier, that's using the database directly. And so it kind of does these things implicitly. But I'm working from it with Python, I actually have to tell it where the database is and make a connection to it. So that is, it opens, it's kind of like when you're on a website or like you're streaming on Netflix or something. Like when you open your Netflix client, it makes a connection to the Netflix servers so it can grab data from it. We're going to do something similar with this database system. So I'm going to create this thing called an engine, and then use this function that I imported from SQLAlchemy called createEngine. And then I'm going to pass this connection string. Don't worry too much about what this means. If you're really curious, go and look up the format and what this does. But for right now, just know this is the correct string to get to my database system here. Now, and remember this is just a debugger, so I can examine values as it runs. Well, let's take a look at what this engine thing is. All right. I type engine. All right, it's a SQLite engine, which is great. So we know it created and connected correctly, which is honestly half the battle sometimes. Now, to be able to actually do anything with it, I need to create a session. And a session is kind of a way databases optimize your inserts and your selects and all that. So in a session, I might insert a bunch of stuff into my table, but then I won't commit it until later, where a commit is saying, okay, you've kind of cached all this stuff over here. Now actually go and write it to my database. Well, I'm going to create a session by using this other thing I imported called Session Maker. I'm going to pass it this keyword parameter bind. So it's saying, hey, create a session for this particular engine that I opened here. And this happens to spit out a session object, which I can call to construct. So just to shorthand it, I'm going to stick an empty pair of parentheses out here. Now remember, I can do that because Python, when it evaluates this as a function. So this will actually return a function that I can call. And since it's a function I can call, I'm going to stick these parentheses out here. Whoops. And that will actually create this session thing, which is great. But that, that doesn't really do me a whole lot of good yet. So I actually want to create a way to connect with the user database. And I do that via this declarative base thing here. So I'm going to create this thing called base. I'm going to do that. Declarative base is going to provide a bunch of table definitions for me from this database. Now remember, I'm using these SQL terms like table and all that. Don't really get too bogged down in that. Just be okay with it. If you're super interested, by all means, go look it up. But that should become clear as I type some of the more of this code out. Anyway, so how I'm going to kind of define that user table I have in SQLite in Python is with a class, which I'll call user. I'm actually going to inherit this base. Now, we didn't really talk about inheritance too much, so just kind of know you have to do that. And so how I connect this to the actual table is I'm actually going to define this class level property called table name, which should be the same name I gave it in the table. So now if you remember down here, my table is called user undercase u. I'm going to stick that as my table name right there. But not only do I need to give it the table name, I need to tell it what columns this table has. Well, my user table has username, which is going to be a column that is a string. Now here, SQLAlchemy has these types defined for me. So you can kind of see in this example they have here how they define those. So for example, I have this column, which is a function, or a class more or less, and I give it the type, and I'll explain that here in a minute, what that means. But notice I need to actually import that from SQLAlchemy. Now you might notice here they put commas next to these to put it in one line. I put them all in different lines. It is completely up to you how you want to do that. This, I've always been told, is better style. I couldn't tell you exactly why. I mean, I guess it kind of looks a little neater, looks more fancy. But either way is like perfectly valid ways for importing stuff. Alright, anyway, so I'm going to tell this a string. And I'm going to set this keyword argument, primary key, equal to true. And what that's going to say is all my usernames in my table, so this is just a table, so it's going to have several rows with all these different usernames. That primary key is just going to say, hey, this username has to be unique. So no two rows in my table can have the same username. So just like, I don't know, you're on Reddit or something. Like no two people can have the same username. That's all it's saying. I also have this password, which is a column that's a string. And this string can map to the text attribute in SQLite. So they are the same thing. So I believe. We might find that's wrong, but I'm pretty sure that's correct. Like I said, there's about 1,000 flavors of SQL. I actually work most with Postgres. Anyway, that's besides the point. So now I have, now I have this user class. Awesome. So since I inherited this base, it actually gives me an implicit constructor. But notice here, just like they did, you can actually define it yourself. So just for clarity, I'm going to go ahead and define my init, where it takes the username and password. Awesome. Cool. So now I can define a user like that. Right? Just a normal class. It's just got a little extra stuff that because of the SQLAlchemy, we can now connect to our database. Now, how would I actually go and insert something into that guy? Well, I'm going to do that via this session. So let's say that I want to create a new user. I'll use Daniel as an example. And he has some password. I create this new user. Well, now I want to actually add that, excuse me, add that to my database. So I want to add this as a user row to my database. All right. Well, so I can take my session, and there's this function called .add. And I literally just give it the instance of user. And then I commit. Now let's make sure this worked before I explain. It might not. Okay. So that guy ran with no errors. So let's take a look at our database and see if it worked. Now, this is a little confusing. Again, I'll explain that here in a couple minutes. check it out. Daniel some password is now in my database. Awesome. So remember this class, by inheriting the base, giving it this table name attribute, and defining these columns like this, that's saying, hey, this class user, an instance of it, so remember when I construct it, represents one row in the database, in the user table of the database. And it connects because of this attribute right here. So when I construct this instance, I give it the username and password, I get this instance of user. So then this session is what will actually go and write that to the database. So I add user, which is all fine and dandy, but that doesn't actually touch the database yet. That just says, hey, I'm going to be doing something with this later. It does it in transactions, which I won't explain right now. Just know this won't write to the database yet until I call session.commit. So session.commit is what's actually going to say, okay, I have this instance, sorry, or it might be multiple instances. I could have defined another one. This time we'll use Nicole. I could add another one and added that as well. Sorry, cannot type today. And then this commit will write both of these. So in fact, let's go ahead and try that. It'll make a good point. So there's Nicole, and now Daniel's in there twice. Now remember I said this primary key set should only be once. Well, for SQLAlchemy to be able to define this and catch an error on it, I actually needed to have defined my username here as a primary key. Now notice, remember I can bring up the schema. Notice I didn't do that. Let's go ahead and do that. So I'm going to recreate my user table. Now, having dropped it, I now have gotten rid of everything. But that's okay. I can define that guy to be a primary key. I believe that's how you define it in SQLite. It didn't give me an error, so I'm assuming so. So now, let's run this again. Okay, now we have our Daniel and our Nicole in here. That's awesome. Now, if I run it again, notice it gave me an error. Integrity error. Meaning an integrity error is saying I'm violating this primary key constraint here. Meaning I can't insert another Daniel or another Nicole because they already exist in the database. Now you can actually import this error and use it in a try except to test if something already exists. But I'll leave that for a self-study, if you will. Anyway, cool. So just to be clear, I'll leave that in there, but I'm going to comment it out. Now, how do I get things out of the database? So to do that, SQLAlchemy has a mapping to select statements. Now you'll have to, excuse me, I'll have to go find it again. Ah, there we go, okay. And so when you want to get something out of a database, whether it be just a bunch of data or you're aggregating it, it's called a query. And so session has this built-in thing called, a built-in function called query. Which means, hey, I'm going to ask the database about some information. So let's say I want to get the usernames of all the users in the database. Well, a good place to start would be right there. All right, throw a debugger in there so I can see what that was. Notice it actually gave me back 2 user objects. Which means result sub 0 is a user, which means it has a username, which is Daniel, and a password, which is some password. So then a simple list comprehension would give me all the usernames. Remember, since this is a list of user objects, I can say, well, for R and this, I chose R arbitrarily. Well, then R is a user object, so that I can say r.username. So then my result, oh, I didn't save it, whoops. So then my result are the 2 usernames. Cool. Well, so that's really about it. There's obviously some much more complicated stuff you can do with this. Database systems and query languages are an entire series of classes in a CS major. It gets very complicated, especially working at it with Python like this. So I can make a series of these classes that represent all kinds of different tables in the database. I can join them. I can aggregate a bunch of them. I can get some statistics on it. But this just kind of showed you some basic, or give you some basic knowledge of, hey, I can map my database into Python and then just manage things with Python objects, so I can still use my list comprehension, I can use my classes, all that stuff. So you can kind of abstract out the actual database part of it, which can be really useful. Anyway, that's about it. I'll be recording another one tomorrow, which I will post over building. It'll kind of build off of this actually, and we'll put this into a module and build a basic web server off of this that'll be able to do some login stuff, which will be pretty cool.